Hello, I'm Doc Sketchy, and this is the Beast. This is my handmade homage to the Korg PS-3100. I call it the DS-3100, which stands for Doc Sketchy 3100, obviously. So basically it's a 48-key polyphonic synthesizer where every key is a separate synthesizer, just like the original Korg unit. Except this one, I've designed all the circuitry myself and built it all by hand. So the first thing I'm going to do is give you a quick tour of the what it consists of. We'll start with the power supply. It's over here. So these are Meanwell 5 amp 15 volt switching power supplies. There's two of them, and they're wired up so that this one generates -15 and ground, and this one generates ground and +15. So I get a dual power supply out of that. Right. The next thing to talk about are these 6 boards under here. I can't really show them to you. I'm going to show you a graphic a little bit later, but these are the gate logic. Well, I guess before I talk about that, I should talk about the keyboard just briefly. So this was a let me turn that down. This was a keyboard that I scavenged from an old organ, and it was originally a matrix keyboard, and I couldn't use a matrix keyboard, so this was the original PCB from the bottom of it, and you'll notice that it has these contacts. These are for bubble switches. A bubble switch is like a dome of rubber, with like a hollow dome of rubber, and it's got a little carbon contact stuck inside it. And so when it gets pushed down, it connects the lower comb and the upper comb together and makes a contact. So what I did is I made my own little contacts on PCBs. I couldn't make one big long one, so I made 4 shorter ones. So instead of diodes and matrix connections like this one has, there's just 48 connections to the 48 keys. So when a key is pressed, when the keys are unpressed, they're just not connected. But when a key is pressed, it just connects to ground, and that causes the gate to happen. Okay, so then there's a lot of logic in those gate circuits, which I'll talk about in a minute. These up here are the VCOs. There are 12 VCOs, and each VCO is then divided down to 3 octaves, so it's 4 octaves altogether. So each VCO basically makes 4 of the same note. And then those VCOs go into these boards. These are what I call WVV, Wave Shaper Voltage Control, VCF, VCA. So they're basically the voice cards. And there's 2 voices on each board. So there's 12 here and there's 12 here. So 24 of those boards. And then underneath, there's again 24 in total of those. These are the envelope generators. So there's 2 envelope. Well, there's actually 4 envelopes on each board. 2 for the a pair for each voice. 1 for the voltage controlled filter and 1 for the voltage controlled amplifier. So that's the total. So that whole thing is what I call the Beast. It's the core of the synth. And then over here, I have some other stuff. This is all just temporary for testing purposes. Let me get this out of here. So this little board has 3 things on it. This is just the volume control. So there's a VCA. So what happens is each 24 voices from here get summed into one, and these 24 voices get summed into one, and those 2 voices come into a VCA on this board and then go out to the final output. Now there's 2 other things, these 2 knobs here. These are what we call keyboard scaling, and this one's for the filter cutoff, and this one's for the loudness, for volume. And what the keyboard scaling does is you can emphasize one end of the keyboard versus the other end of the keyboard. And the keyboard scaling boards, if we look under here, you see there's a little board underneath this board. That's the keyboard scaling board. There's actually 2 different ones. There's one on the back side as well. And these gray wires on this side, and then the blue and purple wires on this side connect to those. So these gray wires are for the amplifier scaling, and on these ones, the blue wires are for the filter scaling, and the purple wires are for the output. So the output of each voice card goes down to the scaling board as well. I'll talk about that a little bit later as well. All right, and then the final thing, then there's these switches. Now, the outer 4 switches don't do anything. They were for a previous test. These switches, one is for fifths and one is for what I call fat octaves. And then these switches here, there's a sustain switch, which will keep a note on forever. So I'll just demonstrate that. So now there's no fifths, there's no octaves. So if I play just a note, let me turn off this this really nice reverb unit I borrowed from a buddy. Let me turn the resonance down a touch so it doesn't make that weird sound. I'll turn the release off a little bit. All right. Now let's put on fifths. Okay, now let's put on octaves. So the octaves, every C plays exactly the same thing. Because well, except for that top C, which doesn't actually work. Because that would be key 49 and there's only 48 keys. Yeah, so in octave mode, you get all 4 octaves with every key. And then, so then there's sustain, which is pretty obvious, and that will eventually be hooked up to a pedal. And then there's toggle sustain. There's a second switch for toggle sustain. And what toggle sustain is it allows you to turn keys on and off. This is particularly useful for tuning. Yeah, so gotta be careful with it though. Okay, so, and then the final thing to show you is this board here. This is my panel mock-up. Now, I'm going to explain what all these things do. These faders on this side are my waveforms. So I've got sawtooth, triangle, and pulse. And then this is pulse width, and this is pulse width modulation attenuator. Then these are the 2 envelopes. So here's ADSR for the filter, and the strength, what I believe was called expand on the original 3100. Except my filter expand is bipolar, so you can have right side up filter, right side up envelope, and upside down envelope, which is very useful. And then this side is the amplifier ADSR, and it's amount control, and this is only monopolar, because there's no point in having a bipolar amplifier envelope, because it's already off at 0, so there's no point in going negative with it. And then this is filter cutoff, filter resonance, and cutoff modulation attenuator. And then so mine actually does 3 filter modes at once: low pass, band pass, and high pass. All right, and then this circuitry is the panel control circuitry, and I'll talk about that a little bit more in a few minutes. Okay, let's play some sounds, put this thing through its paces a little bit. I've set up just a kind of a bass sound here. Turn it up a little. First thing I want to demonstrate is the keyboard scaling. So if I turn the keyboard scaling all the way up, you get higher cutoff up at the top of the keyboard and lower cutoff at the bottom. So and if I turn it the other way, you get the opposite. So this is useful if you want to have like a plucky bass sound. Maybe a little less plucky. Okay, and then you get the opposite with this. Could be useful. Now this is loudness scaling, but I can't really demonstrate it because it's not really working correctly because I used the wrong resistor value. I need to change 48 resistors, and I haven't gotten around to that yet. So that's that'll have to be for another video. All right, let's. So what we're listening to there is sawtooth, sawtooth and low pass. Now let me demonstrate a negative envelope. I'll turn the envelope down and then I'll go negative. So here's negative, but I have to turn the cutoff down. It's a bit ugly, but yeah, so you get the idea. All right. Let's see here. So let's listen to, let's blend in some pulse. Turn the sawtooth. Well, we'll just do pulse. There's pulse width modulation. Okay, and then we've got triangle. Triangle's a bit weak. I just turn the I guess we could do yeah. That's triangle. All right, let's leave it with sawtooth, and let's listen to band pass. Upside down band pass. high pass. And let's do high pass pulse. And we can blend. Let's blend pulse, and so let's blend all the waveforms. And all the filter modes. Didn't sound like much, actually. Now let's look at filter resonance. Filter resonance all the way off. Let's just do low pass. And then let's get it all the way up. It doesn't self-oscillate, but it does get pretty crazy at the top here. Let's see. Dial it back a little tiny bit. Let's put the sustain on. Put the fifths on. Let's see. Oh yeah, here's something cool. If you put on a long decay, a long decay, and a very low or zero sustain, then it takes quite a bit of time to go from the high frequency, the high cutoff down. And if you have a lot of resonance, you'll hear all these notes happen. So let me do that. I'll just play a couple of C triads. Oh, let me put the sustain on. Okay, and then yes, let me do that again. And listen for the extra notes that come in afterwards. I have fifths on as well, so there's a lot going on here. Didn't quite do it. Let's try it again. Yep. I think I needed higher cutoff. Let's try it again. Try it an octave down. Anyway, it makes a lot of sounds. Let's put this reverb on, and this reverb is really nice. And let's try that again with the reverb on. Anyway, that's just a little taste of the beast. Oh, yeah, before I forget, let's turn that down and turn off the fifths. All right, so It tracks really well. Just play a triad here. Let me set my wires get crossed. So at the lowest octave, this is the highest note. This is the lowest note. So the low note of the piano would be here, I think. So these notes are all below the piano. I think I'm going to just have 4 octaves on the actual unit. I think that's about it. All right. Okay, so given that I'm a professor, I couldn't resist giving a little PowerPoint lecture here. I'll try not to take too long. So what we see here is the block diagram of the beast. So we've got the VCOs, which generate a constant sawtooth. They go into the saw shaper, which generates sawtooth, triangle, and pulse, and gives us pulse width modulation. Those 3 waveforms are mixed in a 2164 waveform mixer. 2164 is, of course, the quad exponential VCA that I use in all of my designs. From there, and those are controlled by the panel faders. From there, it goes into the state variable filter, and the state variable filter, we have control over the cutoff frequency, the resonance, and frequency modulation. The first ADSR envelope generator controls the filter, and it has a bipolar control. The state variable filter generates high pass, band pass, and low pass modes, which are again mixed in a 2164 mixer controlled by panel faders. The output of that goes to the final VCA, which is controlled by the second ADSR, which has monopolar control. And of course the gate from the keyboard or whatever controls, triggers or gates both ADSRs simultaneously. So that's the basic outlay of the beast. Just talking about the gate logic circuit slightly. This is how the gate logic works. This is my own design. I'm not going to go into detail with it, except to say that the toggle sustain is actually controlled by a flip-flop, and I was a little concerned that was going to be touchy because it was going to I was going to have switch bounce issues from the keyboard, but I don't. I also wanted to shout out to my fellow mod wiggler, whose name escapes me at the moment, who turned me on to these 4085 logic block ICs. These things are the bomb for this application. So this is what the gate logic board looks like. This is from my Excel-based layout tool that I use always. What we see here are that down here we have the notes coming in, and then these are the notes a fifth down for the fifth mode, and then each note. So let's see, yeah, each note, each of the 4 notes. So this would be, for example, this would be all of the B naturals, I guess. No, all of the B flats. So each of those 4 notes has its own gate logic circuit. So there's 8 gate logic circuits on this board, and the gates out are here. Okay. This is the VCA board, and basically it's a very simple VCA based on a 2 transistor exponential converter and a 2 transistor This capacitor, 2 transistors, and 2 diodes are the core of the VCO. So split right down the middle here. There's one VCO on the right, one VCO on the left. This trimmer is to adjust the DC level to eliminate a glitch when you divide down. This trimmer is the 1 volt per octave calibration, and this outside trimmer is the actual tuner to tune the note you want. And then down here, all this circuitry, including this IC, are for the divide down for the 3 octaves lower. So these show the 6 VCO cards with the 12 VCOs mounted on their base, and this is the 6 gate logic circuits, each with 8 gate logic circuits on 6 boards mounted to its base. Okay, so let's talk next about the ADSR boards. So the two ADSRs are on one board. This is what the board looks like. There's actually 4 ADSRs on here because there's 2 voices. So these 2 are for one voice and these 2 are for another voice. And then up here is all the circuitry for expand, for the level control. I'm using AS3310 ADSR chips from Alpha in Latvia. They work very well. The next board we'll look at is what I call the WVV, which it stands for Wave Shaper VCF VCA, and you might just think of it as the voice card. So all this stuff is on one board. That's what that board looks like. So down here we have this is 2 channels. So this over here is one wave shaper for channel 1. This over here is another wave shaper for channel 2. And then up here, one of the channels is above all the chips, and the other channel is below all the chips. And these are basically identical circuits above and below. And so the signal comes in from the right. First goes through the AS3350 alpha dual state variable filter chip. And then this circuitry is for getting the various modes out of the filter: high pass, band pass, low pass. And then these 2164s are for the control of these 3 are for the control of the filter modes, and then this last one is for control of the final VCA. This is the final VCA, basically. Okay. This is what the envelope and voice card boards look like sitting on their bases. Now you'll notice these extra chips down here on the base. I want to talk about those briefly because this was a real innovation for me. But before I do that, the last boards we'll talk about are these 2 what I call keyboard scaling boards. So this board here, the bottom one, is the keyboard scaling for 24 of the 48 keys for the VCA. So this is for scaling the volume across the keyboard. So a voltage comes in here, and then a voltage comes out here and goes to an identical board that has 24 more. So and then the end of it is connected back to the control circuit. So what the control circuit does is it generates a positive voltage here and a negative voltage here. And so that gives you the ability to generate a straight line of voltage across this whole circuit that can tilt up or tilt down across the whole keyboard. And because these are only 200 ohm resistors, and they feed into a 200K resistor on the voice card, there's virtually no voltage loss, so you get a more or less a perfect straight line of voltage across all these resistors. Same thing up here. The outer resistors are the keyboard scaling ones for the filter, and it's an identical circuit to this one. And again, they're 200 ohm on this board, and they go into 200 kilo ohm resistors on the voice card. So there's a 1,000 to 1 impedance ratio, which means that these keyboard scaling voltage generators are very stiff. The two inner, these 30K inner resistors here are for the outputs. So each voice comes out here, and they get summed onto these common, this common line, which goes into an external 2164 VCA. So these are currents. So I don't have to worry about shielding this or anything, or impedance, because these are currents, not voltages. And the input of a 2164 VCA is a virtual ground, but it's not a high impedance input. Okay, so here's the beast all wired up. So you can see the various blocks, the VCO, the gate logic, the two voice card blocks on top, the two envelope blocks on the bottom. And a friend of mine very graciously machined these aluminum rods so that I could connect these plates together and build this superstructure. I just wanted to talk briefly about the panel control circuit. Now this is not the final circuit. This is just a test mock-up. But basically you'll see that there's a lot of these 2164s on here. And so, for example, this is the side that controls the three waveforms and the one of the envelope amounts. And then this is the side that controls the three filter modes, and then the other envelope generator. And then these are the envelope controls and the filter controls in the middle. So these 2164s are and the associated op amps on the outside here. These are set up as logarithmic amplifiers. I'm using what's known as the Irwin circuit, linearized 2164 VCA circuit. Anybody who designs synthesizers today will be very well familiar with the circuit by Mike Irwin that was published in a magazine article 20 years ago or so, that talked about how these are exponential control VCAs, but the Irwin circuit allows us to linearize them by using two VCAs. One is a logarithmic amp, and the logarithmic amp takes the input control voltage, converts it to a logarithm of itself, and then uses that to control the exponential amp, and a logarithm into an exponential gives you back linear. So it's a very clever circuit. What I'm doing is I'm using logarithmic amps here to control 48 exponential VCAs. So one logarithmic amp, for example, this one that controls the sawtooth amount, will control all 48 sawtooth VCAs on the voice cards. Now, anybody who's done electronics knows you can't control 48 things with one thing, because you'll get signal loss because you're not feeding into an infinite impedance. So you can't fan out one control into 48 different destinations. So in order to deal with that, we come back to the bases here, and these op amp chips on the base are basically just wired up as buffers. So the controls come in on these pins, go into these op amps, and what these op amps do is they present an infinite impedance to these inputs. So, and then these op amps will, for example, one of the controls will feed one op amp, which then goes on to all 24 of the voice cards or the envelopes here. And in that way, I don't lose signal, and every voice card or every envelope gets exactly the same control signal as every other one with no loss. I call this local buffering. Here's a schematic of the linearized 2164, where so here's your control voltage, here's your linearizing op amp, and this is acting as the logarithmic amplifier, generating a logarithmic control voltage. Here's the local buffer, and then that presents an infinite impedance in and an almost zero impedance out. and you can control, I show 3 different VCAs, but I'm actually controlling 24 VCAs from each one of these buffers. And it works just fine. The only problem is these buffers do tend to get a little warm, and I bought some heat sinks that I'm going to stick on them. I haven't done that yet. Okay, now I want to do a few more little demonstrations. First, I discovered a very nice harpsichord-like patch. So I thought I'd butcher a little Bach for you. The first piece I'm going to butcher is the Allemande from the first French suite, I guess it's in D minor. And then after that, I'm going to butcher the first prelude in C from the Well-Tempered Clavier Book 1. And then after that, I discovered another little patch that functions a bit like a piano. And so to demonstrate that, I'm going to butcher a little piece by Grieg called Arietta. Okay, so that's basically the video. I had a few final thoughts I wanted to just get in here at the end. First of all, just wanted to mention that if I didn't mention it before, the sustain function will have a foot pedal associated with it. I could have used that during that Arietta piece. There will also be a volume pedal, a swell pedal. I hope it'll be swell. Anyway, the next thing I wanted to mention was just to contrast a little bit with the PS-3100. On the keyboard scaling, looking at the PS-3100 schematic, as far as I could tell, and somebody in the comments can correct me if I'm wrong on this, but as far as I could tell, all they did was they split the keyboard up into the bottom half and the upper half. And so basically for the scaling, they made the bottom half quieter or louder and the top half louder or quieter. Whereas what I've done is I've introduced a circuit that introduces a loudness or cutoff frequency gradient across every single key from top to bottom, with the fulcrum in the middle of the keyboard, right between the middle B and C of the keyboard. The other thing I wanted to mention specifically about the keyboard is that the Korg PS-3100 keyboard was F to E, 48 keys. This keyboard, I couldn't find an F to E keyboard. All the keyboards I had were C to C, 49 keys. And so it's very annoying to have that top C that doesn't play. I'm sorely tempted to build a separate voice card with a VCO, a simplified gate circuit, and the whole ADSR and WVV circuits just for that high C. We'll see if I get around to that or not. But I must say this keyboard that I've found and with the contact boards that I built is very responsive. You might have noticed in one of those Bach pieces that I tried to play that I was able to get some very delicate fingering things going on. So staccato, legato, you can be very sophisticated with your touch. It's almost like a real harpsichord in that way, which is a nice surprise. Also, I wanted to just point out that this is just the core circuitry of the synthesizer, but there's going to be a whole lot of post-beast circuitry. For example, resonators, the general envelope generator, some effects, for example, chorus, reverb, different things like that. Yeah, so, and I don't know how much of from the original Korg, you can plug external things in, external controls and whatnot. I'm not sure how much of that I'm gonna reproduce, but there will be some of that as well. Also, in the modulation, I didn't show you any modulation because I don't have any modulation sources here, but there's going to be at least a triple morphing LFO, like the famous Korg MS-20 LFO. I will put at least three of those on here. So those you can shape from sawtooth to triangle to reverse saw, or you can do pulse. And I tend to also add polarity switches so the pulse can just be positive or positive negative or just negative. There will also be a sample and hold and a noise source. So you'll be able to get the computer talk effect. And you'll be able to play big chords and have the random computer talk thing going, playing all the chords at different notes. I may even throw in a bit of a quantizer for that effect to keep it all in tune. We'll see. I haven't decided. And then the final thing I want to say, this is just a shout out to my fellow mod wigglers who have gone through this, seen all my trials and tribulations with this thing. And one of the last things that I had a hard time with was getting it to be in tune and to stay in tune. And the long story short of that was that I had, on my VCO cards, I had the Expo converter transistors arranged front to front, like both pointing in the same direction, with the Tempco resistor in between, stuck in there with thermal paste. And the bottom line was that the two transistors weren't in intimate enough contact thermally, so they were responding to temperature changes and sending the tuning all over the show. So I turned one of the transistors around on each VCO and made it so that they were touching. I pushed the Temco resistor down onto the board so it wasn't between the two resistors, so the resistors are touching, and I actually wrapped them with electrical tape so that they're in intimate contact. And that solved my tuning problems. Now the tuning is very stable. In fact, for basically all the demonstrations I did in this video, I just turned it on and I let it warm up for a few minutes, went and got a cup of coffee or something, came back, and then it was in tune, still in tune from the day before. So that's a big deal. Now on the just like on the Korg PS-3100, on my panel there will be 12 micro tuners down the left side of the panel, 12 mini pots where you can tune each note individually. In the Korg owner's manual, it says those are for getting, just intonation tunings like like Kernberg or Werkmeister or whatever from the old Baroque days before they used our equal temperament system. But I think that's a big pile of crap. I think what they actually are is because the Korg PS-3100 probably had to be tuned every time you turned it on. So those mini tuners are there just to get some semblance of decent tuning every time you play the damn thing. But mine is pretty stable, so I'm happy with that. All right, I think that's all I wanted to say for this video. So if you made it to the end, thank you very much for watching the whole thing. And I'll make another video when I get more of it done, and maybe when I get a panel on it, and maybe even a case. So we'll see about that. All right, thank you very much. Till next time. Doc Sketchy signing out. Last thing, a bonus patch. I discovered this patch yesterday and saved it as a photograph. So I tried to reproduce it. It's a very weird patch.